Hello guys, um, you're welcome once again. In this lesson, we are going to investigate how pressure is affected by surface area and by weight or force. Now, recall that in your year 7 and your year 8, you were taught the basic procedure in investigation. You were taught that for you to investigate any concept, any idea, you need to ask questions. For you to have any scientific investigation, you need to ask questions. And then you need to suggest an explanation, or sometimes we call it make a prediction, isn't it? And then we need to test our prediction or our explanation using experiments. And then you need to check the evidence from the test, if it supports it or not. That is, if the test supports your prediction, you need to check it and see. Then if it supports it, you finally accept that prediction that you make. Okay, that's by the way what you guys did. Today we are going to focus on having the test itself. Okay, now for you to make a test, for you to carry out a test in the lab, there are certain things you must know. Okay, this test here, what we are actually doing here is a simulation of what we should do on the lab. Okay, we are assuming we have two identical blocks, red and blue, and then this is a clay soil, this is a clay. Okay, this block can actually cause deformation on this clay, that is, can actually make a slight indentation or a hole on the clay, okay, which can be measured. All right, so our aim of this experiment is to actually to see if weight, not just weight, and the surface area affects the pressure on this soft soil here. Okay, the apparatus we will need, our apparatus is actually what we need. I'm going to leave that to you to decide what we're going to use. Okay, a worksheet is there for you to decide the apparatus we use. And the next one is the experimental procedure. Okay, these are some of the steps, things you must pen down when you're carrying out the step. The experimental procedure, what are the procedure, what are we going to do, or do we do to be able to achieve our result? I'm going to leave that to you. You're going to pen down the procedure we are going to carry out, we are going to take. Okay, and then the analysis means the table you're going to draw out and the result you're going to come out with. Okay, from the result you can come up with a conclusion, right? Good. So that's exactly what we are going to do today. We're going to focus on the test part of our scientific investigation. Okay, all right, so the first thing you write on your rough book is the weight of each of this block. The weight of the block is 0.3 Newton. Okay, are we good? So you can pen it down on your rough paper before you write it on the table. I will tell you how to write your table. I will tell you, I'm going to give you a worksheet where you see all those steps on test, how to report your test. Okay, all right, so on your rough paper, quickly write 0.3 Newton as the weight of the block. Okay, so what we will do is we are going to after that, measure this distance. Take your ruler and measure this distance. I know you're using different devices to view what I'm doing, irrespective of the devices you're using. If you're using a computer or you're using a mobile phone, take your ruler and measure this depth. Okay, this depth here. Okay, write it in your rough paper. I'm going to tell you how you are going to put down everything on your table later. Okay, are we done with that? So get the depth of this one and get the depth of this one. You can record it somewhere rough in your rough paper. Okay, so I'm going to add another block on this and another block on this. Okay, so how much weight do I have now? Remember I said the weight of one block is 0.3 Newton. Okay, so I have two blocks here. What will be the weight? The weight of one block is 0.3 Newton. So what will be the weight of two blocks? Record it somewhere in your rough paper. Take note of all what you're recording. Make sure it's neat. Later you're going to organize it on a table. The same thing applies to this 0.3 and 0.3. Have you done that? Record the distance. Use your ruler to measure the depth, the deformation, depth of the deformation. This one here, okay, and this one here. Use your ruler and measure the depth. Okay, have you done that? Good. Record it somewhere. Now we're going to add another block to each of this. So we have what we have now: 0.3, 0.3, 0.3. You know the new width now, right? Same thing applies here. We know the new width. Can you measure the depth? Use your ruler to measure the depth. I'm sure your answer is going to be different from that of your friend. Don't worry about that. It's because you're using a different device, a device different from that of your friend. Now measure the depth here also and record it somewhere. You can say depth 2 if you want and record it. Okay, then I'll add one more and one more. So what is the weight here? What's the weight here? You know the weight here now? You know the weight here now? Good. 0.3, 0.3, 0.3, 0.3. You can add up. 0.3, 0.3, 0.3, 0.3. You can add up. We know the new weight. Then measure the depth of this, and then measure the depth of this and record it somewhere. Are we good? Now the last one, we're adding one more block to this, one block to this, one block to this. Now what is the total weight? Now record it. What's the total weight? Record it somewhere in the rough book. Also measure the depth here and measure the depth here. Are we good? Now how to present your table? Now to present your table, you have to draw 4 columns. 1, 2, 3, 4, or rather 5 columns. Okay, 5 columns. 1, 2, 3, 4, like the way you draw your tables. 5 columns. On the first column, write experiment. How many experiments did we do? 1, 2, 3, 4, 5. 5 experiments, right? So 5 experiments. You're going to write 1, 2, 3, 4, 5. Okay, under it, 5 experiments. You have your worksheet, everything is there for you. Look at it, you see exactly what I mean there. Now in the first one you have weight 1, W1. Weight 1 stands for weight of the red block. So for the first experiment it was 0.3, isn't it? The second experiment, when you added another one, what will it be? Record it. 0.3 plus 0.3, isn't it? Which is 0.6. The third experiment, it will be, you have to keep summing it up. Record it. Now in distance, for the distance you have to put S, or the depth you have to put S slash centimeter. It means S per centimeter. Okay, now record the distance, each of the distance, the one you recorded in your rough paper, the first length, the second one, just like that. all the distance you measured. When you added only one block, I mean for the red block, what was the distance? Record it. When you added the next block, what was the distance? Record it. Okay? Are you done with that? Now we'll move to the blue block. For the blue block, the weight of the first one is 0.3, weight of the second one is 0.6, weight of the third one, when you added the second one it was 0.6, when you added the third one, the weight now become what? You have to keep adding 0.3, 0.3, right? The weight becomes 0.9. You do this the same for others. Now the distance, that is the next column, distance. The distance / centimeter, you have to record each of the distance you recorded in your rough paper earlier. Okay, so when it was 0.3, what was the distance you measured, or what was the depth you measured? So when it was 0.6, what was the depth you measured? So record them there. Are we good? Okay, once you've done that, you can come up with a conclusion. What do you think is a conclusion? Does it support the fact that pressure increases when the surface area is small? Does it show that your distance measured? Does it support the fact that pressure increases when the weight increases? Alright, so whatever is your conclusion, I want you to put it down, to pen it down as your conclusion of this exercise, okay, or this experiment. Are we good? Okay, now the worksheet attached to you, make sure you fill them accordingly and then submit it on Google Classroom. Thank you.